use to solve number 5?
You could use the inverse, cosine inverse.
No. Here's the thing. You're going to use your trig functions on right triangles only.
Okay.
On all other triangles, like these 4 that you're looking at now, you can't, you got to use either the law of sines or the law of cosines. So which one do you use on number 5?
You could use law of cosines.
No. Always, first of all, the law of sines is much easier. So always look to use the law of sines if you can. What do you need to use the law of sines?
Sine A over A.
What concept do you need?
Big A's and little A's.
You need an angle and its opposite side.
Yeah.
In other words, if I gave you a triangle like number 6, there's no angle opposite side relationship. But also number 8, there's no angle opposite side. In other words, they're always going to give you 3 pieces of information, okay? Every one of these problems, they've given you 3 pieces of information. And they ask for a 4th, but asking for a 4th is like solving the whole triangle. But in this first problem, we have an angle and an opposite side. So always use the law of sines if you can.
Okay.
So what's the law of sines going to say about this problem?
Sine of big A.
First of all, before we get into the law of sines, let's look at the triangle. They've given us 2 angles. Can we add anything else to this picture without doing much work?
The third angle.
What is it?
42.
Okay. Now, what's the law of sines for W? Start with the one angle side relationship that you have.
Ooh, okay.
Start with the sine. Since it's the law of sines, it's got to start there.
Okay. Sine of 72 over 15 is equal to sine of 42 over W.
There you go. Now that's the only variable. And so you can cross multiply to give you sine of 72 times W equals 15 times the sine of 42, and then divide both sides by the sine of 72, and you have W.
Okay.
Okay? And just always remember that when you're looking at things like that, that's just a number. That's not a variable. That's a number.
Okay.
So when you get it down to 3 numbers and a variable, you can always solve for the variable.
Okay.
Now, as long as we're talking law of sines, let's do number 7 at the same time.
Okay.
So what's the equation going to be for number 7 in order to solve for y?
Sine of 25 over 6.5 equals sine of y over 14.5.
Good. Now let's solve this one. You got your calculator?
Yeah, 1 second.
because this is slightly more difficult to solve for.
Okay. So
that's the first thing, right?
yeah.
All I did, notice I did not cross multiply. I'm trying to solve for the sine of y, so y multiply by 6.5 and then have to divide by 6.5 in the very next step. So all I did as a first step was multiply both sides by 14.5. Come up with that number.
I got 0.94.
Okay, so 0.94 is equal to the sine of y. What's y equal to?
This one, do I use the inverse sign to find?
Yeah, that's why this problem is slightly harder than the other one. Is because the first thing you solve for is actually the sine of the angle. And then in order to get the angle, you have to take the inverse sine of that quantity. So what happens when you take the inverse sine of 0.94?
You get about 70 degrees.
There's your answer. Okay. So both of those problems, 5 and 7, we were able to use the law of sines because we can see right off the get-go that we have an angle and its opposite side. Down here I have this angle and its opposite side. As long as you have that, you don't ever need the law of cosines. But number 6, we don't have an angle and its opposite side. We have x, but that doesn't count. When I say we need an angle and its opposite side, we need the measurement of that angle plus the measurement of its opposite side. What we have in 6 is side, side, side. So, how are we going to solve 6?
You have to use the law of cosines.
What's the general equation for the law of cosine?
A squared minus 2ab.
Hold on. Let's start with the left side of the equation. A squared equal to?
A squared is equal to a squared plus b squared.
No, these letters are always different than this. So a squared is
a squared equals b squared plus c squared.
Minus what?
2bc. Times a, is it?
Cosine. It's the law of cosines, remember. And yes,
cosine a.
This angle is always the same as this letter. Now, there's actually 3 of these things. Notice the pattern. It's always the other 2 sides. Okay? So c squared would be equal to a squared plus b squared minus 2ab cosine of c. So for this problem, they don't have anything labeled. We don't have an a, b, or a c. What can you give me as an equation to use?
Alright, so we could do...
Since we're trying to solve for x, okay, in other words, we know that the cosine of x goes at the end, so let's write that. So what goes on the left side of the equation?
19.
19 squared. Now the rest is pretty easy. What goes here?
24 squared. Minus 16 squared.
Hold on. Every one of these is plus.
Oh, plus 16 squared.
And the Pythagorean Theorem is plus. In other words, there's your Pythagorean theorem, basically. Okay? And
Yeah.
what are we subtracting?
224 times 16.
Times cosine of x. Now, we're going to have to go through all that math. In other words, we're going to have to square each one of these. In other words, this is now, there's only one variable, x, so we're going to be able to solve for it. But there's a land mine full of potential mistakes to be made. So let's just go through this solution.
Okay.
Tell me how to solve this equation, all the way down to getting x.
Well, first you multiply out all the squared
Go ahead and do
things.
it. Let's do it. What's 19 squared?
Okay.
And this is the way I actually recommend
361.
doing it. Don't try to do it all at once. Square each of these, add those two, multiply those three. Do it step by step. So what's 19 squared?
Okay. 361.
24 squared?
576.
16 squared?
256.
2 times 24 times 16.
768.
Next step.
You can add together the two in the middle.
Okay, and that gives you 832. Now what?
And then you can subtract 832 on both sides.
Okay, what's that give you on the left?
471.
Negative, right?
Yeah. Yeah.
And the negative's important because if you accidentally had it positive, then you're going to have a problem because then you're going to end up with a cosine of x equals a negative number. And that's going to actually give you a strange looking answer. Whereas notice now I got a negative sign on the left and I got a negative sign in front of the cosine x. So now what?
You can add 768.
What is 768 doing to that cosine x right now?
Being multiplied by it.
So you always do the inverse.
Oh, okay.
In other words, you want to divide by negative. If I'm trying to isolate that, which is the first step, before I solve for x, I got to isolate cosine of x, then I got to divide both sides by this coefficient that is currently multiplying cosine x.
That makes sense.
So what do you get for cosine x?
0.61.
Now how do you get x?
Find the inverse cosine.
Go ahead.
Uh, 52.17.
Okay. And does that look like a reasonable answer for x?
Yeah.
Yeah, it does. And that's all we need. But I bet you anything on a test he's going to say solve the triangle. Don't just give me x, solve the whole thing. Well, the rest of it, solving it, involves finding the remaining two angles, right? But
Yeah.
once I've solved for x, now what's the next step? If the question were solve the triangle, what's the next thing I can do?
You could use that and the law of sines to find
Yeah,
other
the law of
angles.
sines is always the next step. In other words, even on problems where the first step is the law of cosines, the second step is always the law of sines. Because once you've solved for one of these angles using the law of cosines, now you have an angle opposite side relationship. And the easiest way to solve the rest of this triangle is by using the law of sines. Whenever you have an angle opposite side, instantly you're ready to use the law of sines. Okay? And that will give you this either angle you want, depending on which side you use. And then the very final step, you're going to have two angles and three sides. How do you get that third angle?
Just subtraction.
Yeah, so you actually, on this problem, you use three different techniques to solve the triangle. The first one is the law of cosines to solve for an angle. Second one is the law of sines to solve for one of the other angles. And then the third is to just use the property that the angles add up to 180 to get the third angle. Now, number 8 is also a law of cosines problem. And it's also one that isn't labeled with letters. So you have to be a little bit intuitive as to how we're going to use the law of cosines here. What's the equation going to look like? Oh, that's z, excuse me. Always start on the left side of the equation, even if you're going to use the law of cosines.
Okay.
So remember what our equation looks like. Our equation looks like this. Okay, so the only angle that I possibly have for A is going to be 44, right?
Yeah.
So on the left side of the equation, I have to use the side that's opposite that angle.
Okay.
So what's the equation going to be?
Z squared equals 8 squared plus B squared minus 2.
Equals 8 squared plus 10 squared.
Yeah.
Minus 2.
Minus, yeah, 2 times 8 times 10, cosine 44.
Yeah, and now everything on the right side is a number that you can get out of a calculator. And then once you get that number, take the square root of it, and you'll have side z.
Okay.
All right. Let's look at these word problems. Let me make fun of his word problems. Hold on. Oh. No, I can't make fun of it yet. No, in fact, I can't make fun of any of these. Didn't we have one the other day that said a cliff cast a shadow, and that a 6-foot tall person standing at the base of the cliff, what kind of shadow is he going to cast?
Yeah.
The reason I made fun of it was, if the cliff is casting a shadow, how are you going to see the shadow of this 6-foot tall guy? And the answer is you would not. Not unless he was, I suppose if he was not standing inside the cliff, he was standing next to the cliff. Or instead make that a building instead of a cliff. And now instead of standing next to the building, he's standing towards us, away from the building, such that his shadow is out here. Then you could maybe do it. But let's take a look at this here. Now this is something I don't know how to, I know how to do this. Hold on a second. Yeah. All right, let's see if we can draw this picture. There's psi.
Okay.
There's a shadow. These are always right triangles, incidentally. Well, not always.
Okay.
Most of the time they're right triangles. Okay? And its shadow is 15 feet long, so that's got to be 15 there.
All right.
Angle of elevation from the tip of his shadow to the top of his head is 38 degrees. So which angle are they talking about?
The bottom one?
Bottom left.
Yeah.
That's 38 degrees. There's the tip of his shadow. There's the top of his head. So that angle is 38 degrees. Then how tall is psi? Well, now we have that problem to solve. In other words, our word problem became a very simple, easier than these four problems to solve. Why? Because none of these four triangles were right triangles. This is a right triangle. Remember, you never use the law of sines or cosines on a right triangle. You don't need to. You can just use a standard trig function. What's it going to be? Which trig?
52 degrees.
What's that?
52 degrees.
No, look at this picture. And what we have to figure out is what's going to relate this side, and that angle. So what trig function of that angle relates x and 15? Is it sine, cosine, or tangent?
Cosine.
Let's look at it. This is really important. You definitely want to be able to solve your right triangles. One thing, these are so much easier than these. What is it?
Tangent.
Yeah, in other words, we're looking for something that relates opposite and adjacent, right? If it was sine, it would need to be opposite and hypotenuse. If it was cosine, it would need to be adjacent and hypotenuse. So it's opposite and adjacent. So what's the equation?
Cosine 38.
Hold on, we just decided it was tangent.
Oh, sorry. Tangent of 38 equals x over 15.
That's 90% of the problem. Now you can solve it.
Okay.
Multiply both sides by 15 and you get x. In other words, right triangles are particularly easy to solve. No law of sines, no law of cosines. It's just figuring out the trig function that relates the information. If they wanted to know that was x, then which trig function would I use?
Cosine?
Yeah.
No.
No, you're right. Because what do we know? We know relative to this angle, we know the adjacent and we know the hypotenuse. Or at least those are the three pieces of information. So the cosine of 38 degrees would equal to the adjacent over the hypotenuse. And now, again, we have just one variable we can solve. All right, Mark, gotta go. Got somebody else up.
All right. Thanks, David.
You're welcome. Talk to you tomorrow. Bye-bye.
All right.